Okay, so first part I will focus to the diagrams, diagrams, important diagrams that normally you can recall back a lot of uh, knowledge that we have learned in the SPM level. Okay, so first is the solid. I think 5 electron students, I did discuss some of these questions in the classroom already. So you just recall back now. Okay, so arrangement of solid particles, solid. So solid, remember, minimum 3 times 3 layers. Then no overlapping, don't overlap. Okay, draw slowly, no overlapping. Then no empty space between the atoms, meaning that the 2 atoms here must touch with each other. Oh, you draw it slowly. So this is for solid 3 times 3, minimum. Okay, then for the liquid, okay, a little bit spaces. Okay, but the numbers is still more than gases, but it's less than solid now, less than solid. If you have any question, you on your mic, because I cannot see the chat, your chat now. Okay, then for gases, okay, gas particles, so they are moved randomly. Okay, there are spaces between the gas. Okay. Now this is a apparatus to determine the melting point of the naphthalene. Okay, so any solution, remember, solution, you must have the dotted line. Okay, on the dotted line. Okay, no dotted line, -1 mark. Normally 2 marks for the diagrams. So no, that dotted line will be -1 mark. Okay. Another one is the boiling tube. It cannot touch the bottom of the beaker. Oh, okay. Then after you draw it, if can, you label all the apparatus, including like this here, no wire gauze, right? Okay, kasatawai. Okay. You also label. This one is the tripod stand. Okay, tripod stand. This one is the red top stand with the clamp. Semuanya kamu label dia lah. Okay, label it. Okay, then this is for freezing point. Okay, cooling process. Okay, so we put inside a conic flask. Okay. Then naphthalene. Normally the question, if question asked about the boiling point or freezing point, they use the naphthalene. Then another one example, it would be acetamide. Okay, acetamide. Almost, actually both of them, they are almost the same. Okay. Hampir sama saja. Roughly 78 to 80 degrees Celsius for the melting point and the freezing point. Okay, next is the empirical formula. Empirical formula, there are 2 methods. So this method is used for reactive metals such as magnesium, zinc. Okay, dia pakai crucible. Okay, then you heat it directly. Magnesium ribbon, you rub it with the sandpaper. Okay, then crucible with the lid. And then if this question coming out, you ask you why the lid must be open at intervals. Okay, sekali-sekala kamu kena buka dia punya lid. Okay, penutup dia. So this is for to allow the oxygen to enter. Okay, so that it can react with the magnesium. Okay, then for this coupled to another apparatus, this is for the unreactive metals. Normally, if this setup you will use for copper, lead, or silver for this unreactive metal. But normally they will use copper 2 oxide, copper 2 oxide. Okay, so put it here. Then it need to react with the hydrogen gas. Hydrogen gas. So how to uh, react it with the hydrogen gas? Okay. So here zinc react with the acid. Okay. A metal with the acid will produce a hydrogen gas. So hydrogen gas pass through the hot carbon oxide. So it can displace the copper. Okay. Then you can measure the mass. Okay, or not? Uh, so far, any question? Okay, no question. Then we proceed. Okay, now electron arrangement. Okay, electron arrangement here. This one is a standard representation X 27 13. The larger number represent nucleon number. Nucleon number 27. Then 13 is the proton number. Nucleon number, proton number. And then if the question asks you about the neutrons, will be nucleon minus the proton. Nucleon number minus the proton, that is the 14. Then electron arrangement will focus the proton number 13. Shell 1, 2, then shell 2, 8, shell 3 maximum 8. The remaining 2 will be at the shell number 4. Here will be 283 now, 283. So 2, 8, second shell will be 8, then 3. Okay, 283. This is for electron arrangement. Then normally the nucleus will write in the formula here. This one is aluminium actually, X here. Then if you don't know what is it, you can follow the one here, X. Then we'll put the circle for it, showing it is a nucleus. So nucleus, we don't draw any electrons at the nucleus here. Okay, no? So we draw another shell for this first shell. Okay, shell number 1. Yeah. So this is for electron arrangement. Then another one is the atomic structure. Atomic structure. The only difference with the electron arrangement, it has the protons and the neutrons. You have to mention how many protons and how many neutrons. You can draw a line like this and then you write outside here, or you can write inside here if your space is big enough. Okay, no? So you have to be careful. Atomic structure or electron arrangement. You have to differentiate it. Okay, okay, next one is the reaction of alkali metals with the oxygen. Alkali metals with oxygen. So alkali metals like lithium, sodium, potassium react with the oxygen gas. So we put it inside a gas jar so that they can react. This one we call it combustion tube. Combustion tube. Sorry, combustion spoon. Okay. Then another one is a reaction of the alkali metals with the chlorine. So same apparatus, just the gas here is the chlorine, not the oxygen anymore. Okay, on it. Then another one, okay, is the iron with the chlorine gas. So here one reminders here. Whenever you want to draw the stopper, okay, stopper cannot fully insert into the combustion tube or test tubes or boiling tube. Okay, must be like a little bit coming out here, like this. Okay, so this one is iron with the chlorine. Then you will form the iron 3 chloride, not iron 2, iron 3 chloride. Okay, next is the electron arrangement for compound between S and T. So let's say X is 19 protons or 19 electrons. So it's 2881. Okay, 281. T is 8, so it'll be 2 6. Okay, 2 6. So for this case, we will know it is metal with non-metal. So metal, non-metal, it will forming the ionic compound. Huh? Ionic compound. Okay. So 2881 to achieve octet electron arrangement. So you will lose 1 electrons to the T. Huh? So once you lost 1 electron, so becomes 288. So positive 1. Okay. Then if 1K here or S lost 1 electron, so you will receive by the T or O actually. So it becomes 27, huh? 27. So 27 is still not stable octet electron arrangement. You still need another one. So that's why it needs another potassium ions. So these potassium ions, you will lost another electrons here. Okay, so that's why it receive 2, so 2 negative. Once you see the positive and negative charge, directly you know it is a ionic compound. Involve the metal with non-metal. Okay, metal with non-metal. Okay, gain or loss the electrons, not sharing the electrons. Must be gain or loss electrons. Okay. At the end, all the ions, you will achieve octet electron arrangement mostly. Yeah. Okay. So its bond will be ionic bond or ionic bond. Okay. Another one is the covalent compound. Covalent compound, you won't see any charge. Okay, you won't see any positive or negative ions. You see like intersection like this. This is we call it sharing of electrons. Okay, sharing of electrons. So contribute, menyumbangkan how many electrons for sharing. So like say hydrogen is 1, right? Carbon is 6. So carbon should be 2, 4, right? In order to achieve octet, you still need another 4. Hydrogen, 1. So you need another 1. So it shall contribute 1 electron for sharing. So carbon contribute 4 electrons for sharing. So it share with 4 atoms of hydrogen. Okay, so that's why it becomes CH4 with 10. Okay, so sharing of electrons. Okay. Okay, next, we come to the electrolysis. Okay, electrolysis. Okay, under molten state. Molten state. Okay, so molten state is you heat the insoluble salt normally, or ionic compound like molten lead to bromide. It is insoluble, so you cannot make it to solution. So you have to heat it until it is melt. Okay. So normally we'll use the bulb or ammeter to show the flows of current here. Okay, so whenever you want to use the switch here, if you want to use the switch also can. Okay, make sure that the switch must be turned on. Okay, must be on. Okay, this is for solution. Okay, solution normally we use the dotted line now. Dotted line. Okay, sodium chloride solution. Okay. Okay. Then electroplating. Electroplating. Let's say you want to electroplate iron key or spoon. It's up to you. Up to the question actually. Okay. Remember, the spoon or the key must be put at the negative shorter line here. Cathode. Okay. Then the electroplated metal, meaning that, let's say you want to electroplate your key or spoon with the silver. So the silver metal must be put at the positive or anode. Remember, anode undergoes oxidation. Oxidation. Then here we undergoes reduction. And then this key or the iron spoon must be fully covered by the electrolyte solution here. Cannot be going not cover, must be fully covered. Okay. So this is for when the question asks you to draw the diagrams. So make sure that you draw it correctly. This one is a real step actually. Then the silver nitrate solution, the solution must contain the electroplate metal ions. Let's say silver, you want to electroplate the key with the silver, right? So the solution must contain the silver ions. Okay, let's say here you want to electroplate with copper, so the solution must be copper 2 sulfate solution, for example. Okay, here you must be it reject the silver chloride. Okay, so remember, silver chloride is insoluble salt. Is insoluble salt. It is exists as the solid. Exists as the solid. Okay. Then purification. Again, you see here, if got switch, make sure that it is closed. It is closed. Cannot be open. So the pure copper or pure metal put at the anode. Sorry, cathode, shorter one. Then impure one, impure copper, we put it at the anode. Okay, shorter. Longer one, sorry. Anode undergoes oxidation, cathode undergoes reduction. The electrolyte must contain metals that you want to purify. Okay, but normally the question will use the copper as an example. Yeah. Then simple vortex cell. Okay, vortex cell, remember, is a chemical cell. You won't see any battery. Okay, no battery. No battery. Okay. So here, okay, how to determine the anode and cathode? So we will use the E0 value or E0 value. The more negative value or more negative sign, negative value becomes the anode undergoes oxidation, lost electrons. So magnesium is more negative E0 value, so becomes the anode. Okay, so you lost the electrons, undergoes oxidation. So lost electrons, then electrons will flow through the wire, connecting wire, goes to the cathode here. Cathode will undergoes reduction. Reduction. Okay, so you will be asked to label the flows of the electrons. Very popular question. Okay, next, Daniel cell. Daniel cell, it is separated by the salt bridge or the porous pot like this. Okay, both can be accepted. Daniel cell can be used as salt bridge or porous pot like this. It is separated by the salt bridge. Normally salt bridge is the potassium chloride, potassium nitrate. These two are the most common one. Again, zinc and copper. You see, zinc dip into the zinc sulfate solution. Copper immerse into the copper 2 sulfate solution. Oh. And again, we have to determine the anode and cathode. So zinc more negative anode value. So becomes an anode, undergoes oxidation, lost electrons. So electrons is lost. A lot of electrons is scattered here, so it flows through the connecting wire, gained by the copper, undergoes reduction. Okay. These are also the same. You see, zinc put inside the zinc sulfate, copper put into the copper 2 sulfate solution. You exchange this also can. It means that this one is zinc, this one must be the zinc sulfate solution. Then this one is copper, this one is copper 2 sulfate solution. Okay, also can. And then porous pot, it has very tiny like hole, allows the flows of ions. Okay, then for titration. Okay, titration is for the neutralization. Okay, neutralization. Okay, between the acid and alkali. So under titration, normally we use a phenolphthalein as the indicator. So phenolphthalein in the alkali will be pink color or purple. Then the acid will drop in. Initial volume of the acid you record first. Then you drop down again slowly. Then once the pink color turns to colorless at the end point here, meaning that the alkali is neutralized by the acid already. Then you stop. You record the volume of the acid used to neutralize the alkali here. Okay. This question also very popular, Very popular. Okay. Then to test the gas, right? Okay, this one is a very popular question to test the carbon dioxide. So any metal oxide like zinc carbonate, calcium carbonate, marble chips is a calcium carbonate. You heat it, you release the carbon dioxide gas. Then you pass the gas into the lime water. Lime water. Then what is your observation? The lime water turns cloudy, showing that carbon dioxide is present. Okay, so for this, you have to know how to draw the diagrams. Stopper cannot fully insert into the boiling tube. Okay, next is the arrangement of atoms in the pure metals. Okay, it will be like this. For this one, you see, it will be slightly different with the solid, right? Okay, solid will be all the atoms will be like one row, okay, or one column. But this one is like at the middle here, right? This one layer 1, layer 2. It be the atoms will be at the middle of this. Okay, so this is for pure metals. All the atoms in the pure metals are the same size. Same size. Then the layers of the atoms, they can slide over one another easily when the force is applied. Okay, so it can slide over because the same size, right? So it becomes less hard, less hard. Okay, and then less strong. Huh? Okay. Then for the alloy, okay, like say in the bronze. Okay, so bronze, it has a foreign atoms. That is the tin, yeah, under bronze, tin. Then this one is copper. Okay, then the foreign atoms are, it has the different size. Okay, you have to mention about the different size of the foreign atoms. Then what happens? It will disrupt or disturb the orderly arrangement of the pure metals like this. This one is orderly arrangement, right? Arrange it the orderly in the layers. But this one, it will disturb the orderly arrangement. Okay. Then when the force is applied, then the atoms cannot slide over one another easily. Okay. One is trying to slide, right? It is blocked by these thin atoms, which is a bigger size. It will block already. So it cannot slide over one another easily. So that's why the alloy is harder, and then it is stronger. Okay. Okay. Now to determine or to compare the hardness of the brass and the copper, or bronze with the copper. One is the pure metal, another one is a alloy. Okay, so this is the apparatus. We hang the metal. Okay, we hang the weight. Okay, on the top of the block here, and then we have the steel ball bearing. Okay, then once you have to hang it at the same levels. Oh, then after that you cut it. Then the weight is fall down. Then knock the steel ball bearing. Then steel ball bearing will knock the bronze block here. Here should be brass block now. Okay. Then we see the dent. Okay, we see the dent form. Okay. Then brass is bronze is harder, so the dent form is smaller size, smaller dent. Copper is bigger size. Sorry, bronze is less. Sorry, copper is less hard, so it forms a bigger diameter of the dent. Okay. Okay, we continue. Okay, let's say this one, if you see this, okay, C double bond C, then OH except one, Cl. This one, remember, is the chloroethene or vinyl chloride. It is the monomer for the PVC now, PVC pipe. Okay, so this is the monomer, this is the polymer. In the polymer, there is no double bond, no more. Okay, so this one is called polychloroethene. Okay, so monomer normally no word poly lah. Polymers just add in the word poly in front of it, like this polyvinyl chloride. This is a PVC. Okay, then propene. You see here, C double bond H. Then this one is one CH3. So in the polymer, you see polypropene, double bond no more. Okay, because it forms two new single bond. to connect with another monomer here. Okay, so this one is under polymerization. Then polymerization, it has two types, addition polymerization. Another one is what? Condensation polymerization. Okay, all these are addition polymerization because all monomers are the same. Okay, simple one, same monomer. But condensation polymerization will be two different types of monomer. Huh? Okay, next is the rate of reaction. Determines the rate of reaction between the calcium carbonate is the marble chips, calcium carbonate. So in exam, if you see marble chips, that is a calcium carbonate actually. React with acid, it will produce a carbon dioxide. That is all. Then stopper again cannot fully immerse. If you are asked to draw the diagrams, make sure that you draw it correctly. Okay. Then this one is a burette, is the inverted, inverted. The stopper is outside here. Okay. Then here the basin filled with water. Then here the level of this delivery tube must be lower than the water level. Cannot be higher than the water level here. Okay. So this is for determines the rate of reaction. If collect the gas, if the reaction involves the release of the gas. So the easiest way for us to calculate the rate of reaction is collect the gas over the time. Okay. This one for hydrogen gas, also release of the gas. So we use the metal with the hydrochloric acid, or zinc with acid, magnesium with acid also can. We release the hydrogen gas. Okay, next one is another one is a sodium thiosulfate with the sulfuric acid. Okay, so this one we will draw a cross or mark X marker on the white paper, and sodium thiosulfate react with the sulfuric acid. Okay, our I will be on the top. Okay, then the time taken for the X mark cannot be seen. Okay, it's recorded. Then we can calculate the rate of reaction. The yellow precipitate will be the sulfur. Sulfur is a solid, so you cover the X mark actually. Make the X mark cannot be seen. Okay, then rate of decomposition of the hydrogen peroxide in the presence of the catalyst. Okay, so here one without catalyst, another one with catalyst of manganese oxide. So with catalyst, you will light up the glowing wooden splinter. It will light up. Okay, then next one is structural formula for the propane. Propane, 3 carbons with alkane, right? Alkane or carbon-carbon single bond. Okay, so propane. So make sure that you can draw in at least 1 or 2 questions in the exam. For the carbon compounds, maybe alcohol. Okay, let's say 3-methyl pentene. Okay, so we draw the parent chains. Pentene, pen is 5, right? 5 carbons. At carbon number 2, it has double bond. So 1, 2, 3, 4, 5. 5 carbons. Carbon number 2, it has double bond. Then at carbon number 3, so here is 1, 2, right? So this one is done. Carbon number 3. At carbon number 3, it has 1 branch with 1 carbon, methyl. Methyl is 1 carbon. If ethyl will be 2 carbons, Okay. So 1 carbon, so at carbon number 3. Then draw all the hydrogen. So here, I suggest you to draw all the hydrogen by drawing out the bonds here. 1 carbon, 4 bonds. So here you can check 1, 2, 3, 4. Here already 4. So don't put any hydrogen here anymore under carbon number 2. Otherwise you'll be wrong. Okay, okay, then isomers. All isomers is C5H10. H12. This is a pentane. Okay, pentane. So it has 3 isomers. So 5 carbons. All are single bond. Okay, so this one is straight change now. Straight change. Pentane. Then after that, you take one of the carbons becomes a branch. So branch, don't put at the last carbon. You put at the second one at the branch. So this one becomes 2-methyl butane. You see, butane here. You don't put at the last carbon if last carbon is still the same as pentane. Then after that, you take another branch. In another carbon becomes a branch. So put at the center again. Don't put at the side here. If put at the side, it's still the same actually. So 2,2-dimethyl propane. So there are 3 isomers. Okay, So I will suggest you to draw and then you name it. Okay, you name it so that you will you'll get the correct one. Then isomers for butene. Okay, C4H8. Butene, it has double bond. So double bond, it has more possibility here. So build 1 in, carbon number 1. See? Then you shift the double bond to the second carbon, so it becomes a new isomer already. So this one is build 2 in. Is that okay? Then after that, you put one of the carbon becomes a branch. Okay, so becomes 2-methyl propene. Okay, propene. Any question, class? So far, okay. So alcohol also the same, alcohol. Sometimes you see some reference book, you write like this. I will suggest you to draw out, easy for you to see. Okay, to calculate whether it's CH2 C3, CH3 you can calculate the bond. Each carbon, it has 4 bonds. Then you won't get wrong. So butanol, it has four isomers. For me, I think it won't ask you to draw the isomers for the butanol. Maybe propanol. Okay, propanol. Less isomers. Propanol, propane 1O, propane 2O. Yeah, at least 2 isomers. Okay, then butanoic acid, carboxylic acid. So here, butanoic acid, so 4 carbons, 1, 2, 3, 4. Okay, so it has COOH, carboxyl group. Okay, carboxyl group. So C, carbon bond O or H. Then at carbon number 2, it has 1 branch with 1 carbon. Okay, so this is the butanoic acid. 2-methyl butanoic acid. Okay. Okay, then for the ester, propyl ethanoate, the 1 methyl group, okay, or methyl group, alkyl group is from the alcohol. So another way is for you to see is where is the C double bond O. Okay, C double bond O. That one belongs to carboxylic acid. So carboxylic acid here is a ethanoic acid, becomes a ethanoic. So ethanoic meaning that two carbons are 1, 2. Or 1, 2. So this one belongs to carboxylic acid. Carboxylic acid. So ethanoic acid. Then propyl is the alcohol. So 3 carbons, 1, 2, 3. 3 propanol. Propanol. Okay. Then this one you see, I purposely change it to so still the same. So if you are given this structure, C double bond O, okay, so this part belongs to carboxylic acid, butanoic. Butanoic, so it's a butanoic acid. Then this one becomes the alcohol, so it be methanol. Okay. This one you can draw a straight line, then continue here. No need to go down like this. Okay. Now how to prepare the fermentation of glucose? This one your bio also got this question also. So glucose with the yeast. Then you fermentate and release the carbon dioxide gas actually. Then it turns the lime water to cloudy. Okay, then dehydration of ethanol. So this one quite popular apparatus. You need to learn how to draw. They will produce the ethene gas to be released here. Ethene gas. So stopper cannot fully insert into the combustion tube. Okay, then oxidation of alcohol become the carboxylic acid. So become ethanoic acid. Oxidation. So oxidation, strong oxidizing agent. Acidified potassium dichromate 6 solution. So orange turns to green. Another one is what? Acidified potassium manganate 7. 7. Okay, that one will be purple to colorless. Okay, with alcohol. So oxidizing agent with alcohol. Then you heat it, then you release you produce the carboxylic acid. Carboxylic acid. Then you can get the carboxylic acid here. Okay, carboxylic acid, it has a low boiling point. So once you heat it, it will vaporize. Then here will be condensed back, so you can get the carboxylic acid here, ethanoic acid. Okay, then ethanoic acid. Another method here is using the reflux method. Here, so the same alcohol with the oxidizing agent, like potassium manganate 7 solution. Okay, then you can get the carboxylic acid also. Okay, for the Levy condenser, okay, the water in must be from the lower level, lower level. Okay, which is the anti-gravity or anti-gravity. Okay, next is the esterification. Esterification, very simple one. If come out in the exam essay question, what is the ester you want to produce? Okay, you have to determine first. Let's say here, ethanol with ethanoic acid. So ethanol becomes an alkyl, ethyl. Ethanoic acid becomes ethanoic. So here we can becomes a ethanol, ethyl ethanoate ester. Oh, so let's say in exam essay question asks you to prepare one ester, so you get the alcohol with the carboxylic acid, then drop in some few drops of concentrated sulfuric acid into the mixture, then you heat it. You heat it, then it forms two layers. Two layers. Okay. Then you get the ester. 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 It has a fruity smell, and it is insoluble in water. Uh, okay, for natural rubber is isoprene. Isoprene. Then this is a natural polymer. Natural rubber is polyisoprene. Uh, you see here, double bond got two under isoprene. But here, single bond here, single bond by here, change to double bond, polyisoprene. Okay, yeah, this is the unvulcanized rubber. Okay, unvulcanized rubber, no sulfur links. Okay, no sulfur links. So this one, the rubber molecules, it can slide over one another easily when the force is applied. So it is less elastic, or less elastic, less hard. But here is a vulcanized rubber. It forms a sulfur crosslinks, like this. So it make it more elastic. Very difficult to slide over one another easily. And then when you release the force, you return to its original shape. Okay. Then this is compare the elasticity. Okay. Okay, next is the transfer of electrons at a distance. Okay, so no battery. Normally we use the galvanometer. Okay, so iron 2 sulfate solution. This one very popular example. Iron 2 sulfate solution, and then acidified potassium manganate 7 solution. Using the U-tube. Okay, and the U-tube here will be sulfuric acid. Okay, so observation here, purple turns to colorless. It is iron 2, you will change to iron 3. So green solution, it turns to brown color, which is Fe3 positive. So this one undergoes oxidation. This one oxidizing agent undergo reduction. Reduction. Okay, next is compare the rate of rusting. Okay, when it is contact with different type of metal. So remember, if you see the blue spot here, showing that iron nail rust. Okay, when it contact with less electropositive metal, such as a copper, lead, okay, or this silver. Okay, then pink color, it shows the iron nail does not rust when it is contact with magnesium or zinc. Okay, so pink color shows the hydroxide ions actually, and for the phenolphthalein, hydroxide ions is present. So iron nail does not rust. Okay, so here this metal is protect the iron from rusting. Okay, the heat of combustion. So remember, if you are asked to draw the diagrams, I hope you remember this experiment, because school exam I gave 2 times in the essay question, asking you to determine the heat of combustion. So remember, don't use the beaker. We use a copper can. Why use copper can? Because it can conduct heat easily. It's a metal. Then here not the alcohol put inside the copper can. Is the water. Okay. Then alcohol put inside the spirit lamp here. Okay. So this is the apparatus to determine the heat of combustion. Oh, okay. Energy level diagrams. Okay, for exothermic, remember energy must be labeled. Reactants, products, then delta H need to mention. So if you see like this, going down the staircase is the exothermic. You will see delta H got the negative sign. Endothermic is positive sign. Positive sign. Okay. Next is the SOP. SOP. Okay. If you are asked to label or to circle, okay, the head is hydrophilic. Hydrophilic soluble in where? In water. Hydrophobic tail. Okay, this part soluble in the grease or oil. Oil. Detergent also the same. You see, for salt is carbonate. Okay, carboxylate. COO. But for the detergent is the sulfonate. SO3 or SO4.